Okay, in this problem, I want us to use a fundamental theorem of calculus, part one, which some people interchange part one and part two, but when they're saying this problem, there's by part one they mean this. If we take the derivative of this integral from a to x of f of t dt, it's just equal to f of x. Okay, so basically, if it's in this format, you're just replacing the t's with the upper limit on that integral, which is x. So it might be a little confusing, but let's see. Here's a problem where f of x is equal to negative 1 to x t to the fifth dt. So I think we can see that it kind of fits in with this up here, but they want us to find f prime. What does f prime mean? The prime means derivative. So basically when they say f prime of x, we want to find the derivative of this thing that they gave us. Okay, that's what f prime of x is. And if we look at it, it kind of fits in with up here. We have d dx of an integration where x is the upper limit on the integration. It's in regards t to the fifth dt. What does that tell us? It's just equal to f of x. Basically, we just have to take the function that is in terms of t and put it in terms of x. That's it. That's all I want for f prime of x is x to the fifth, according to that fundamental theorem of calculus. Then they might ask you, okay, well then what's f prime of 3? So we already know that this is equal to f prime, right? X to the fifth is f prime of x. So for f prime of 3, you just plug in 3 wherever you see an x. And 3 to the fifth, I believe, is 243. Basically, you're just fitting this into this format. We do have an x as the upper limit of integration, so you just rewrite the function instead of in terms of t, you can write it in terms of x, and that will be equal to your derivative of that integration. Okay? And then for this part, you're just plugging in a number. So I hope that helps.